Good evening, everyone. Welcome to today's live session on indefinite integration. Right? And if you remember in my previous video, we already discussed about method of substitution. Right? Okay, so once again, I'm welcoming everyone on this live session on indefinite integration. So here, from the last lecture, we started a very important section of indefinite integration called method of substitution. And let me tell you, friends, this is nothing but the heart of the integration. If you want to be really good in integration, make sure that every one of you are perfect in substitution. And in my previous lecture, we already got an entire idea about the method of substitution. So substitution is all about two-step process. First, this what exactly you are substituting is important, and the derivative of that substitution. So substitution and its derivative, these two steps are very important in substitution. And always remember one particular sentence, that is, substitute the term whose derivative is present in integration. So friends, we already discussed every detail of this method of substitution in my previous lecture. I hope every one of you really enjoyed that last session. And today I am going to cover the next important part. This is actually a continuation of the previous lecture, that is on substitution. But in this session, I'm going to cover this very important thing, that is nothing but I'm going to discuss important corollaries based on substitution. And if you remember, integration is an antiderivative process. On the basis of that, we derived all the list of standard integrals. But out of that entire list of standard integral, if you remember, these few standard integrals was missing. So today we will derive these four important standard integrals, means integration of tan x, integration of cot x, integration of cosec x, and integration of, let me correct it, the last one, it's not cosec, but it is an integration of sec x. So the last one in the list is integration of sec x. Okay, so these four standard integrals are missing. If you remember, this is not a part of, so let me correct it little bit. The last one is integration of this cosec x. So here I am correcting this last one. This cosec comes f. So here I am going to cover these four standard integrals. The first one, integration of tan x, integration of cot x, integration of cosec x, and the fourth one is integration of sec x. Okay, so friends, once again, I welcome every one of you in this today's live session on indefinite integration, in which I am going to continue the last session on method of substitution. If you remember, in method of substitution, two steps are important. First, what exactly you are substituting is important, and the derivative of that substitution is important. So the step number one, substitution. Step number two, derivative of that substitution. And always remember one very important sentence: substitute a term whose derivative itself is present in integration. So we discussed everything about this substitution in my previous lecture, and in this live session I'm going to cover or going to discuss few important corollaries on substitution, and along with that we will derive these four standard results, that is integration of tan x, integration of cot x, integration of cosec x, and integration of sec x. So let's start this today's session with important corollary. The first one in the list is, so please write down, this first important corollary is integration of f dash of x upon f of x with respect to x. So answer is log of f of x plus c. Let me tell you, friend, these corollaries will help you in objective examination, because these corollaries always saves your time, right? So to solve a method problem by substitution, it takes little bit time, but this definitely this corollaries will save your time in objective examination. Also, you can apply these corollaries in theoretical examination. So here on the left hand side, if you observe, the function is given in the denominator and exactly the derivative of that function is given in the numerator. In simple language, function is present in the denominator and its derivative is present in numerator, then in such cases final answer is log of f of x. Why it is so? Let's try to find out. So here I am starting with the left hand side of this corollary, which is f dash of x upon f of x. Don't worry friends, I am going to discuss all these corollaries along with examples so that it will give you a clear-cut idea about these corollaries. So I will explain each and everything along with examples. So here I am, since these are the corollaries of the substitution, so here I am substituting f of x equal to t. As I already discussed, substitution is a two-step procedure. The first step is all about substituting something whose derivative is present in the integration. And if you observe, the interesting thing is derivative of the function f of x, that is f dash of x, is present in the integration itself. So here I am doing the step number 2. Let's differentiate this function with respect to x. Let's differentiate this right hand side with respect to x. So derivative of f of x is f dash of x. You know that this is the symbolic presentation. So derivative of f of x, symbolically it is f dash of x. This is equal to dt by dx. Please shift this dx on LHS. So finally f dash of x dx is dt. So right, and I'm marking this as a equation number 2, or let me write down in a continuation. So here this f dash of x dx becomes dt, and here I am marking this as 2. So as I already discussed, substitution is a two-step procedure. The step number 1 is all about substituting something whose derivative is present in the integration, and if you observe, this derivative of f of x is present in the integration itself. So therefore I substituted f of x equal to t, then its derivative, and we got this equation number 2 in the form of derivative f dash of x dx is dt. Now let's convert this LHS in the form of t. So here I am writing this left hand side once again, which is f dash of x upon f of x with respect to x, right? Okay, so if you observe, I am doing the substitution. So the step number 1, so substitution for f of x means I am talking about substitution for f of x is t. We assumed it as t, and if you observe, this f dash of x dx is a part of the second equation. So right, so f dash of x dx is dt. So let me explain you in detail. So here I am mentioning substitution plays or replaces f of x. So here I am using the equation number 1, and this f dash of x dx, you have to replace it from the equation number 2. So friends, please try to observe this equation 1 and 2 carefully. So try to observe this equation 1, which leads to f of x is equal to t as a substitution, and equation 2 always helps in replacing the derivatives. So f dash of x dx is dt. So here I applied equation 1 and equation 2 in this given integration. At the end, if you observe, this is a very, very simple integration, which is integration of 1 upon t. So tell me friends, so please send me your answer. What is integration of 1 upon x? So here I'm asking a simple thing. What is integration of 1 upon x? This is the standard integral. If you remember, integration of 1 upon x is log x plus c. Perfect. Integration of 1 upon x is log x. On the similar ground, integration of 1 upon t is log of t plus c. Integration of 1 upon t is log of t plus c, and I request every one of you, please substitute back the value of t, because t is a temporary substitution. So right, t is a temporary substitution. What was the value of t? If you check this equation number 1, please check this equation number 1, the value of t is f of x, right? Value of t is f of x. From equation 1, I am replacing this log x as f of x plus c, and if you observe, this is nothing but the right hand side of this corollary. So please observe this right hand side. So Overall, the corollary is integration of f dash of x upon f of x is log of f of x plus c. This is the right hand side of this corollary. And if you observe, we also got this right hand side as a log of f of x plus c after substituting. So this is equal to RHS. And this is a simple proof of this very interesting corollary. So let me explain you this meaning of this corollary, or how this corollary will help you in solving the integration with this simple example. So for you, here I am writing this corollary once again. So the corollary is, try to understand this nature of the corollary. A function is present in the denominator and its derivative is present in the numerator. See this pattern, friends. A function f of x is present in denominator and immediately its derivative is present in the numerator with respect to x. And answer for such an integration is log of f of x plus c. Please remember, very, very important corollary. So, right? Okay, let me explain you the way that you have to apply this corollary for the examples or for the problems. So here I am taking one question on this. So let's try to find the integration of something. Let's say it's an integration of, in the denominator I am taking tan x, and in numerator it is sec square x. Try to understand, friends. This looks a little bit complicated problem of integration, but let me tell you, this is very, very ordinary problem. If you try to recall this corollary, try to observe one important thing. If you assume this function as a tan x, so what is the derivative of tan x? Try to recall the derivative of tan x. If you remember, derivative of tan x is sec square x. I'm talking about derivative of tan x. So derivative of tan x is sec square x, and if you observe, that derivative is present in numerator. In simple language, function is present in denominator and its derivative is present in numerator. So this is exactly similar to this corollary, where the function is present in the denominator and its derivative is present in the numerator. If it is a situation, so here I am writing in detail for you. The function in this case is tan x, and you know that f dash of x, or derivative of tan x, is sec square x, which is present in the numerator. If this is the case of the integration, then don't waste your time in solving this kind of problem. Directly write down final answer as log of f of x. So please observe this final answer. Final answer in this case is log of f of x. So please send me your final answer for this question. What do you think? What is the final answer for this question? If answer is log of f of x, and in this case f of x is tan x, then final answer is log of tan x, right, plus c. So this is the final answer for this integration. So perfect. So one more example on this corollary. Let's try to find the integration of, here I am explaining you one more example. Let's say it's an integration of, yes, most of you are correct, Darshan, Ritu, Tanvi, Shreyash, Soham, Yash, absolutely correct, friends. So try to solve this next example. What if it is integration of something log x, x into log x? Try to observe this problem very carefully. So here I am taking one interesting question. It's an integration of 1 upon x log x. So friends, here this is all about rearranging a term. This 1 by x, this is 1 in the numerator and x in the denominator. We can express it as 1 by x as a part of numerator and log x as a denominator. So right, and try to observe this thing very carefully. Log x is a function. So here I am mentioning this log x is a function and 1 upon x is the derivative of log x. So right, so if I assume f of x is log x, then you know that derivative of log x is 1 by x. This is exactly similar to our corollary. A function is present in the denominator and its derivative is present in numerator. So are you able to guess the final answer? So please try to write the final answer for this question. Please apply the corollary. The corollary is function in the denominator, derivative in the numerator, and final answer is always log of f of x plus c. Don't get confused with this. So f of x in this case is log x. So final answer for this problem is log of f of x is log x plus c. So this is the final answer for this question. So right? Okay, absolutely correct. So many of you already sent me a final answer. Tanvi, Purva Bafna, Darshan, Ritu Chandani, Manisha Kalkar, Akanksha Veer, Anushka Desai, Rupali Pardeshi. Absolutely correct, friends. So let me explain you one more example on this very, very important corollary. Try to guess the final answer. Don't guess, but try to write its answer perfectly. So here I'm taking integration of cot x with respect to x. So friends, here this is the next question on this corollary, integration of cot x. Integration of cot x. What do you think about this question? Integration of cot x. So see, as far as this corollary is concerned, the function is present in the denominator and its derivative is present in numerator. So we can express this cot x as cos x divided by sin x. So right, we know this simple thing, cot theta. So here I am talking about cot theta is cos theta divided by sin theta. So I'm talking about this simple trigonometry. Cot is cos divided by sin. And if you observe it carefully, this is actually our corollary. A function is present in the denominator and its derivative is present in numerator. So as far as this problem is concerned, if you check, the function in this case is sin x, and you know that derivative of sin x is cos x, right? So what is your observation or what is the final answer? Yes, absolutely correct. So here I am writing a corollary for you. Integration of f dash of x upon f of x with respect to x. If this is the situation, then answer is log of f of x plus c. And absolutely correct. So many of you are writing a final answer perfectly. So final answer for this corollary is, so final answer for this corollary is in log of sin x. Absolutely correct, friends. Here I am writing the final answer, log of sin x. And with this casual discussion on this problem, if you check, we also got a very important standard integral. This is nothing but the standard integral that we missed in the list of the standard integral. So please observe, by discussing this corollary, or while discussing this corollary, we also derived one important standard integral, that is integration of cot x is log of sin x. I request every one of you, consider this as a standard integral. If you remember, I promised every one of you to discuss these 4 important standard integrals. So if you observe, these are the 4 standard integrals that we will cover under this corollary, and we got this first one, that is integration of cot x. And let me write down its final answer now. Integration of cot x is log of sin x plus. So please add in standard list of integral to this formula. So integration of cot x is log of sin x. Now it's a time to solve integration of tan x. So right. So here I am mentioning the next example as integration of tan x. Try to obtain or try to solve this integration of tan x using this corollary. See, we can express this tan x as sin x divided by cos x. So tan theta is sin theta divided by cos theta. And if I treat this cos x as a function in the denominator, what is its derivative? So here I am asking, if I say f of x is cos x, then what is the derivative of cos x? So friends, derivative of cos x is minus sin x, right? Tanvi, you are absolutely correct. Derivative of cos x is minus sin x. So there is a issue of minus sign over here. So do one thing. Let's arrange a minus sign. How to arrange a minus sign? Minus outside the integration and minus inside the integration. This minus minus becomes plus. That gives you original integration. So here I arranged a minus sign in this way. So right now you are free to apply the corollary. So here I am writing the corollary once again for you. It's all about integration of f dash of x upon f of x with respect to x. Answer is log of f of x plus c, right? So answer is log of f of x plus c. What do you think, friends? What is the answer for this question? If I keep this minus sign outside the integration, a function in the denominator, derivative in the numerator, answer is minus log of, understand this, answer is log of f of x, and f of x in this case is cos x. So answer is minus log of cos x plus c. Answer is minus log of cos x plus c. But most of the time we don't like this kind of minus sign as a part of standard integrals, right? So this is actually a standard integral. We want integration for tan x, and we don't like this minus sign in a standard formula. Then what to do? So just try to recall a fundamental thing from the logarithm. If you remember, here I am giving you one important thing or important formula from the logarithm. If it is a minus log a, then we can express it as log of 1 upon a. If you remember, this is a basic formula from logarithm. So minus log a is always log of 1 upon a, and I don't want this minus sign. So let's simplify it in this way. So here I am mentioning minus log of cos x as log of 1 upon cos x plus c. But friends, what is 1 upon cos x? So 1 upon cos x, or cos x is a reciprocal of sec x. Cos x is a reciprocal of sec x. So final answer is log of sec x plus c. And here we got our second important standard integral, that is integration of tan x is log of sec x plus c. Yes, Tejas, absolutely correct. So integration of tan x is log of sec x, and as I already promised you, we are going to derive these four important standard integrals today itself. That is integration of tan, integration of cot, integration of sec x, and integration of cosec x. Out of these four, we already derived integration of tan and integration of cot on the basis of same corollary, that is integration of f dash of x upon f of x, right? So here, now we know the second important standard integral, that is integration of tan x. Now you can write down the final answer for integration of tan x as log of sec x plus c. Now every one of you know these two standard integrals. Integration of tan x is log of sec x, and integration of cot x is log of sin x. So here I covered two important standard integrals. The first one is integration of tan x, and second one is integration of cot x. Still integration of cosec x and sec x is pending. We will work on this one also, so don't worry about that. Okay, then let's get back to the corollary once again. So here I am writing 2-3 important things. So make sure you write down all these 2-3 things as an important note. So first important note is the corollary itself, that is, if a function is present in the denominator and its derivative is present in numerator, then final answer for such a case is always log of f of x plus c. This is very, very important corollary, and definitely this kind of corollaries will save your time in objective examination as well as in theoretical examination. Note number 2 is we derived the standard integration of tan x, and now you have standard formula for integration of tan x as log of sec x plus c. And note number 3 is we also covered integration of cot x with respect to x, which was log of sin x plus c. I request every one of you, please remember these three important things from this corollary. Now, I hope every one of you are writing on the paper. So maths is all about writing everything on the paper. Just don't listen the videos or just don't watch the videos. Maths is all about doing calculations and derivations on paper. So it goes into the long-term memory. So right. So make sure you listed out all these three important things. Right. Okay. So here I am giving you one important problem on the same corollary. So please try to tackle this question. So we already discussed this question yesterday in yesterday's lecture or in the last lecture, and we solved that problem using method of substitution. But instead of that, I request every one of you to solve this particular problem using this corollary, and please check how this corollary saves your time. So the question is 10 raised to x in the denominator and x raised to 10 is also in addition. In numerator they provided you 10 raised to x into log 10, right? It's a 10 raised to x into log 10 plus x raised to 10. It's a 10 into x raised to 9. This is the given problem. So in first glance, if you observe, in first glance, this question looks complicated. This looks horrible. And so many times students get confused with this kind of problem. But let me tell you, friend, this is very, very simple, very ordinary problem. And I hope you can easily identify this is nothing but a standard corollary that we discussed few minutes back. If you observe here, this entire term in the denominator acts as a function and its derivative is present in numerator. So try to observe this thing carefully. So entire denominator acts as a function and its derivative is present in numerator. So let me explain you in this way. So if I consider function as denominator, that is 10 raised to x, x raised to 10, what is its derivative? So friends, what is the derivative of 10 raised to x? Derivative of a raised to x. I am talking about this standard formula. Derivative of a raised to x is a raised to x into log a. On the basis of same formula, this is a standard formula that we know. Derivative of a raised to x is a raised to x into log a. Derivative of 10 raised to x is 10 raised to x into log 10, right? And please apply the derivative to this x raised to 10. For that, here I am using a formula. Derivative of x raised to n is n into x raised to n minus 1. Then derivative of x raised to 10, derivative of x raised to 10 is 10 into x raised to 10 minus 1, that is 9. And if you observe, this is the function and this is its derivative. And this function is given in the denominator and its derivative is present in numerator. Try to observe this entire problem is a standard part of that corollary. So this is the function, this is its derivative. Please try to apply the corollary. Corollary is f dash of x upon f of x. Function in the denominator, derivative in the numerator. Answer is log of f of x plus c. So right. So final answer for this question is log of f of x. In this case is this term, that is nothing but the denominator. Answer is log of 10 raised to x plus x raised to 10 plus c. So friends, so I spent a lot of time in explaining this thing, but these are the not important things for the objective examination. Directly you can write down your final answer and definitely that will save your time. So many of you already guessed this particular answer. Anushka, Purva, Yash Verma, Akanksha Veer, Tejas, Suresh, absolutely correct. This is the final answer for this question and I hope every one of you got this corollary. So right, if it is clear, then please type S so that we will proceed to the next corollary. So friends, here I am asking, is this corollary with example is clear to everyone? Or do you have any doubt? So you can also type. Definitely I will try to help you. Okay, thank you for your feedback. So let's continue with corollary number 2. So please write down the heading. Here I am going to discuss corollary number 2. So second corollary. So second corollary is actually a continuation of the same one. Only thing is it is f dash of x divided by under root f of x with respect to x. If you observe, there is a very slight difference between this corollary and the previous one. Only thing is, if you observe here, the square root is present. This function is present inside a square root. In previous corollary, it was a plain one. So the function was present in the denominator, its derivative was present in numerator, and this one was the corollary. If you observe, what is the difference between these two corollaries is only of a square root, right? So if you observe, the only difference between these two corollaries is a square root. And if you want, you can guess the final answer, but final answer for this corollary is twice of under root f of x plus c. So final answer for this corollary is twice of under root f of x plus c. So let's try to understand this thing with the proof. So here I am starting. So let this f of x equal to t. So once again I am repeating, these are all corollaries on the basis of substitution. So let's start with the substitution. And what you have to substitute? Always substitute a term whose derivative is present in the integration. And if you observe, the derivative of f of x is present in the numerator. So that's why I am substituting f of x equal to t. So if you substitute this thing, then derivative of LHS is equal to derivative of RHS. Then derivative of f of x, symbolically it is f dash of x in maths. This is dt by dx. Then please shift this dx on LHS. So it becomes f dash of x dx is equal to dt. And here I am marking this as a 2. Now, substitution is a two-step procedure. First, the thing that you are substituting and the derivative. So please substitute these two things in the given integration. So here I am writing the left hand side. I am talking about this integration. So try to write left hand side of that integration or that corollary. The left hand side of the corollary is f dash of x upon under root f of x with respect to x. And here I am going to substitute these two equations, that is equation number 1 and equation number 2 in this LHS. So let's try. Substitution is all about change of variable. If you remember, substitution is nothing but change of variable. So please change the variable. So here I am substituting f of x as a t, and then please replace this derivative also, f dash of x dx as dt. So in simple language, if you check, here I am going to use equation number 1 and here I will use equation number 2. So right. So then this is integration of 1 upon root t, and integration of f dash of x with respect to x is dt. Right. So please try to observe this thing carefully. So is it integration of 1 upon root t dt? Yes. Okay. Then the next thing is, try to recall a standard integral. What is integration of 1 upon root x? So please send me your answer. What is integration of 1 upon root x? Try to recall this formula. So please send me, what is a standard integral? What is the standard integral? Integration of 1 upon root x. Yes, Shruti, absolutely correct. Integration of 1 upon root x. Darshan, Shreyash, Parth, Manisha, Ritu, absolutely correct. Suresh, Akankshavir, Deepak Shirsagar, Sunil Karad, Tanvi, Soham, Yash Verma, Tanmay, Vaishnavi Chaudhary. Yes, this is perfect. So integration of 1 upon root x, if you remember, it's a standard integral. Rupesh Tite, Purva Bafna, Tejas, absolutely correct. So integration of 1 upon root x is 2 root x plus c. So friend, this is the standard formula of integration in our list. So please try to apply that over here. So integration of 1 upon root t is 2 root t plus c. Yes, Yash, absolutely correct. Tejas, Purva. Yes, so many of you already know the standard integrals. I am really appreciate that. So integration of 1 upon root t is 2 root t plus c. At the end, substitute back the value of t. So friends, what was the substitution? So if you check this equation 1, the substitution for t was f of x. So here I am substituting back this value of t as f of x plus c. So right, and if you observe, this is nothing but the right hand side of the corollary. So always remember, after the end of the substitution, make sure that you replace the value of t. And if you substitute this value of t as f of x, this is 2 times under root f of x, which is equal to right hand side of the corollary. So please try to observe this corollary carefully. So function is present in the denominator, but it is with the square root, and its derivative is present in the numerator, and final answer is twice of under root f of x, right? So this is the corollary. So here I am writing this corollary for you one more time. So please note down this thing. So it's all about integration of under root f of x in the denominator, and its derivative is present in numerator. In such cases, don't waste your time in solving that entire integration. Instead of that, directly mention this corollary and write down your final answer as twice of under root f of x plus c. Okay, so let me explain you this thing with this simple example. So friends, here I am mentioning this as an integration of something cos x in the numerator, but sin x in the denominator with the square root. So I hope every one of you got this corollary. Please send me your final answer for this question. So it's an integration of cos x divided by under root sin x. Integration of cos x divided by under root sin x. What do you think? What is the answer for this question? Yes, Darshan Patil, Ritu Chandani, Tanmay. Very good, very good. This is the line of thinking that I am talking about. Once we know the concept, we can crack any level of problem. So understanding of the concept is very, very important one. Maths is not about solving the number of problems. It's all about understanding that hidden sense, understanding that concept, right? So many of you are correct. See, I'm really very happy. Tanmay, Shreyash, Tanvi, Shruti, Suresh, Vaishnavi, Soham, Anushka Desai, Akankshavir, Tejas, Rupesh, Manisha Zadov, Yash Verma, Purva Bafna. Absolutely correct, friends. I am really happy that you people are really responding in the right direction. Purva, Yash Bate, absolutely correct, friends. If you observe here, sin x is a function. Sin x is a function, and derivative of sin x is cos x, which is present in the numerator, and it is along with the square root. So in examination, don't forget to mention the function and its derivative. So function in this case is sin x, and you know that symbolically f dash of x or x is cos x. So you are free to apply this particular corollary. F dash of x upon under root f of x. Final answer for this question is twice of under root f of x, that is sin x plus c. So this is the final answer for this corollary. Very interesting problems, right? Very, very interesting problem. Are you ready for the next question? Try to solve. So once again, I am writing this corollary for you. It's a f dash of x upon under root f of x with respect to x, and answer is twice of under root f of x plus c, right? Is it correct? So this is the corollary. Be ready for the next problem and try to solve it. So here I am giving you the next one. The next one in the list is 1 upon integration of x into under root log x with respect to x. Please send me your final answer for this question. So there is a small rearrangement that you have to do first, and after that you will get your final answer. Try to solve this question, friends. Yes. So here I am giving you the hint. See, this is 1 in the numerator and x in the denominator. Try to rearrange it in this way. So it's like 1 upon x divided by under root log x with respect to x. And if you observe carefully, this is the function log x and its derivative is present in the numerator. So right? So yes, I'm really happy that you people are absolutely correct. So log x is a function, its derivative is present in the numerator, and please apply this standard corollary. See, this corollary always helps you in saving your time in solving the questions. So now apply. Final answer for this question is twice of under root f of x. F of x in this case is log x plus c. So is it correct? So final answer is twice of under root log x plus c. Yes, I'm happy that so many of you are correct. So many of you know, 100% of you are correct. This is the thing that I want. I'm really happy that 100% of you are correct in giving answer for this type of problem. So one more for the sake of practice. So it's an integration of, let me give you something different. Integration of under root e raised to x divided by under root 1 plus e raised to x. Don't get confused with this kind of problem, friends. This is a very, very simple, very ordinary problem. So instead of 1, if I write it 2, it doesn't matter at all. So try to guess answer for this. Yes, what is the answer for this question? If you observe it carefully, try to observe it carefully, this 2 plus e raised to x, if you assume this as a f of x, then its derivative is present in the numerator. So here I am considering 2 plus e raised to x as a function and its derivative. You know that derivative of 2 is 0, derivative of e raised to x is e raised to x. So f dash of x is e raised to x, which is present in the numerator. This is the perfect example of this corollary where the function is present in the square root, its derivative is present in the numerator, and this is the final answer, twice of under root f of x. So here I am writing the final answer for this question as twice of under root 2 plus e raised to x plus c. This is the final answer for this question. So right, this is the final answer for this question. Absolutely correct. It is very hard to type mathematical things in chats or messages, but so many of you are typing it very quickly. I am really happy that it's very hard to type the mathematical equations or terms in comment box, but still you are typing very quickly. It's really very a good sign, right? Okay, so here we covered two corollaries. The first corollary was integration of f dash of x upon f of x with respect to x. If you remember, its answer was log of f of x plus c. Then corollary number 2 was integration of f dash of x divided by under root f of x with respect to x is twice of under root f of x plus c. Now I am going to discuss the third one, very important one, corollary number 3. So please write down corollary number 3, that is integration of f of x raised to n, function raised to n. Try to observe this n is an index or n is a power of that function and its derivative is present in multiplication. Then answer for this kind of problem is always f of x raised to n plus 1 divided by n plus 1 plus c. Please observe it carefully. This is almost like applying one standard integral. What do you think? Which standard integral I am talking about? I am talking about integration of x raised to n. If you remember, integration of x raised to n is x raised to n plus 1 upon n plus 1. So right, if you observe, this corollary is exactly similar to this formula, and if I assume this as a x raised to n, this right hand side is x raised to n plus 1 upon n plus 1. So by observation you can remember these corollaries. Here if you observe, this is the function, and this is its derivative. So if you observe all these three corollaries, a function is always there and its derivative is immediately present in the integration, because This is what the substitution requires. A function and its derivative is a problem of substitution. So right, and these are all corollaries that belongs to the substitution method. These are all shortcuts, we can say. So this is f of x and this is its derivative. If you observe, this one is a function, this is its derivative. As far as this corollary is concerned, this is the function and its derivative is immediately present in product. And if you observe, this n is the index of that function or power to this function. So here I am giving you a simple trick or simple hint. Treat it as x raised to n. So friends, what is the integration of x raised to n? It's like x raised to n plus 1 upon n plus 1. So integration of x raised to n is like x raised to n plus 1 upon n plus 1. This is the way that you can remember this corollary. So let's try to understand this corollary with the proof. So here I am starting with the left hand side of this corollary, which is function raised to n into f dash of x with respect to x. Since it is a part of the substitution, so let's start with this substitution as f of x equal to t. So here I am substituting f of x equal to t. Once we substitute, directly start taking the derivative of that substitution. So derivative of f of x equal to derivative of t. Symbolically, derivative of f of x is f dash of x equal to dt by dx. Shift this dx on LHS. So finally, f dash of x dx is dt. Here I am marking this one as a 2. And please substitute these two things, that is f of x equal to t and f dash of x dx dt in this left hand side. So now here I am changing LHS. So LHS was f of x raised to n into f dash of x with respect to x. With these two things, here I am converting this entire integration in terms of t. So it's an integration of, if you check, this is t raised to n. So here I replaced this f of x as t and this f dash of x dx, I am replacing it as dt. So you have to use this equation 1 and 2 to convert that integration in the form of t. So please try to use, so here I used equation 1 and here I replace this entire term using equation number 2. So please observe, this one is all about a substitution and 2 is all about derivative. So right, now this is the final thing. So this is integration of t raised to n. So please apply the standard formula. Integration of x raised to n is x raised to n plus 1 upon n plus 1. You know the standard formula. So please apply. Only thing is it is in terms of t. So integration of t raised to n is t raised to n plus 1 divided by n plus 1 plus c. And at the end, please substitute back the value of t. So what is the value of t? T is f of x. And if you observe, this is f of x raised to n plus 1 upon n plus 1 plus c. This is equal to right hand side of this corollary. If you observe, this is equal to right hand side of this corollary. So please check. This one was given and this one was RHS. Right? So f of x raised to n plus 1 upon n plus 1 plus c. This is the right hand side of the corollary. So here, this is the entire proof in front of you. Please observe it carefully. These proofs are equally important. Once we understand the proof, definitely you will be able to recall this corollary also. So that's why so many times observing a proof is equally important while studying this kind of concepts, right? So here I am writing this third corollary once again for you to solve these questions. So third corollary is like x raised to n. So it's a f of x raised to n and immediately its derivative is present in multiplication. Then in simple language, the trick is treat it as x raised to n and try to recall what is integration of x raised to n. Integration of x raised to n is x raised to n plus 1 upon n plus 1. Answer for this corollary is exactly on the similar ground. It is f of x raised to n plus 1 upon n plus 1. Please remember this corollary. And here immediately I am going to take few examples on this corollary. Try to face it, try to judge or try to crack that structures in examination. So if I say this is the integration of, let's say, sine raised to sine raised to 97x into cos x with respect to x. So many times what I observe, students get confused with this kind of question. But friends, try to observe, don't get confused with this index 97. It is not about that index. It is a sine raised to 97x into cos x dx. Please observe, the function in this case is sine x. This is the thing that you have to observe. Function in this case is sine x, and you know that derivative of sine x is cos x. So please type your final answer then. What if I give you, instead of 97, let's say it's a 99? This is just for the sake of, I'm trying to create it interesting. It's a sine raised to 99x into cos x dx. Now please send me your final answer for this question. The function is sine x, its derivative is cos x. So function in this case is sine x, and its derivative, you know that derivative of sine x is cos x, and this is the corollary in front of you. Treat it as x raised to n, friends. Treat this like a integration of x raised to n. So it's a x, f of x. If you observe this, this is like a x raised to n plus 1 upon n plus 1. So this is f of x raised to 99. Treat it like a x raised to n. So integration of x raised to n is x raised to n plus 1 upon n plus 1 is the final answer. So final answer for this problem is sine x raised to 99 plus 1 divided by 99 plus 1 plus c. But don't write in this particular way. The final answer is sine raised to 100x divided by 100 plus c. So this is the final answer for this question, right? This is the final answer for this question. Observe it carefully. This is f of x raised to n plus 1 divided by n plus 1 is the final answer. Yes, I am really impressed. So many of you are correct. 100% of you are correct. And so many of you also want to write this answer, but it is very difficult to write answer of mathematical expressions in chat. So it's really difficult. So, but still I really appreciate your efforts, friends. Thank you. And here I'm giving you one more question. Try to solve it. The next problem on the same corollary, if I say it's an integration of, something x raised to 4 plus 3 raised to 10 into x cube with respect to x. This is a little bit tricky, friends, but try to crack it. This is the level that you will observe in the examination. So try to crack this kind of problem. So here I am giving you the hint. This x raised to 4 plus 3 will act as a function, and its derivative is present over here. Don't think about constant part. We can always rearrange that thing in the integration. So here I am starting with the function as x raised to 4 plus 3. Then its derivative of x raised to 4 is 4x cube, and derivative of this 3 is 0. So overall, f dash of x is 4x cube, out of which x cube is present, means you have to arrange this 4. So here, this is the way that I am arranging the 4 in this integration. So this new integration is, I am dividing by 4 and multiplying by 4, so that the derivative is adjusted here. So right. So try to observe this question carefully. So here I arranged this 4 to create this perfect derivative as a 4x cube. Now you are free to apply this corollary. So here in this question, the function is this x raised to 4 plus 3. 4x cube is its derivative, and this 10 acts as a n. And please apply this simple corollary. F of x raised to n, please observe, f of x raised to n into f dash of x. Answer is f of x raised to n plus 1 divided by n plus 1. So right. So this is the final answer. So final answer for this question is I hope every one of you already ready with your answer. Final answer for this question is x raised to 4 plus 3 raised to 10 plus 1 divided by 10 plus 1 plus 3. Or directly mention this as 10 plus 1 as 11 divided by 11. So I really appreciate that most of you are correct in this final answer. So I hope all these three corollaries are clear to everyone. So friends, here I am asking once again, is there is any doubt in this corollary? This is a corollary number 1. F dash of x upon f of x is log of f of x plus c. Corollary number 2, integration of f dash of x upon under root f of x is 2 root f of x plus c. Corollary number 3 is integration of f of x raised to n into f dash of x is f of x raised to n plus 1 upon n plus 1. Very important corollaries, and I hope these corollaries will help you in objective examinations too. So right, so you will observe very interesting question. Don't worry friends, in next lecture we will also solve few examples on these three corollaries. Most probably we will try to tackle objective level of problems on these corollaries. Before ending this session, let me cover you this important thing about composite function. Composite function. If I say integration of f of x with respect to x is, let's say, g of x, as we know, in case of integration, the composite part must be linear and algebraic. So if you remember, we already discussed this thing. This is called the composite in integration. So I'm talking about linear and algebraic. Then the way you have to solve this thing is g of ax plus b, and without fail you have to write down the coefficient of x in the denominator. So right, sir, you are the best teacher ever. Thank you everyone. Thank you for this comment. These are the golden words for the any teacher, and I am happy to hear that. So let me continue with this. I already covered a 1 hour, so let me explain you this important thing before leaving this session or ending this session. So here, if you observe, this ax plus b is a composite one, which is a linear and algebraic. And how to solve this thing? So it's a g of ax plus b divided by, this is the important thing, always divide by coefficient of x in the denominator. If you observe, coefficient of x in this case is this a, right? Okay, so here I am giving you the proof of this also. So let's substitute ax plus b equal to t and start taking the derivative of this. While taking a derivative, I am keeping this a outside. So derivative of x with respect to x, then the derivative of individually b, then the derivative of this t. So a times derivative of x with respect to x is 1, derivative of constant is 0. This is dt by dx, right? Further, this is a times, I am shifting this dx on this side, a times dx is equal to dt, or shift this a on this RHS. So dx becomes dt divided by a. So right, this is a in the denominator. Now here I am starting the left hand side of this corollary. So left hand side is integration of f of ax plus b. So friend, just try to observe this proof. It is not at all important for your any kind of examination, but this is just a composite functions concept, and why every time we divide by a, I want to explain that particular reason by explaining this proof. So right, if you don't want to write, so just forget it. There is no issue at all, but please observe why every time we divide by a in case of composite. So this is integration of f of, this one was the substitution ax plus b as a t, and the replacement for dx. Please observe this thing. So here I am using substitution, and here I am using equation number 2. I am talking about substitution in equation 1, ax plus b equal to t. So please observe equation number 1. Substitution for ax plus b was equal to t. And if you observe the equation number 2, dx is dt divided by a. And here I am utilizing these two equations over here. So it's an integration of f of t and dx. I am replacing it by dt divided by a. And as we already discussed, integration of f of x is g of x. Please observe this thing. This is given. Integration of f of x is g of x. So integration of f of t is g of t, right? And this a is a constant, so obviously that will be the part of this answer plus c. So final answer is g of t divided by a plus c. But in substitution, don't forget to replace the value of t. Please observe what is a t. T in this case is ax plus b. So the final answer of the integration is g of ax plus b divided by a plus c. And if you observe, every time in composite, so I hope every one of you watched my video on composite function, and every time if you face a composite function, we always divide by the coefficient of x in the denominator. If you want to understand this thing with this example, if I say it's an integration of, let's say, cos of 2x minus 7. So try to solve this in an exactly ordinary way. You know that integration of cos x is sin x, right? Integration of cos x is sin x, but as per this composite rule, don't forget to divide by the coefficient of x, and coefficient of x in this case is this 2, and don't forget to divide this integration by 2 in the denominator. So this is the thing that I want to explain you from this particular proof. So this proof is not at all important for any examination or for any kind of objective thing, but as far as implementation is concerned, this is very important one. This is the fundamental thing that you have to apply in composite functions. So right, so this is the proof. I think this is clear to everyone, right? Now here I am summarizing the entire today's lecture. So in this today's lecture, we discussed 3 corollary. The corollary 1 was integration of f dash of x upon f of x with respect to x. Answer is log of f of x plus c. Then corollary number 2 was integration of f dash of x upon under root f of x with respect to x. Answer is twice of under root f of x plus c. Then corollary number 3 was integration of f of x raised to n into f dash of x with respect to x. Answer was f of x raised to n plus 1 divided by n plus 1 plus c. Observe this. These are the 3 corollaries that we covered. Fourth one was not exactly the corollary, but it was a rule of the composite. Integration of ax plus b with respect to x is always g of ax plus b, and without fail divide by the coefficient of x if you observe any composite function. Along with that, we derived two standard integrals. So here I am listing the first one, integration of tan x. If you remember, integration of tan x was log of sec x plus c. The second one was integration of cot x, and answer for it was log of sin x plus c. Still 2 integrals are left, but I am keeping that proof with you. So here I am giving you the formulas. So please add these formulas in your list. So integration of sec x is log of sec x plus tan x. As the time is not allowing me further, please write down these 2 standard integrals. Definitely I will send you the proof of this also. So this integration of tan sec x is log of tan of pi by 4 plus x by 2 plus c. And the last one in the list is integration of cosec x with respect to x. Please write down the last one in the list is integration of cosec x is log of cosec x minus cot x plus c, or it is log of tan of x by 2 plus c. So friends, I request every one of you, please don't forget to watch the proof of this two cases, integration of sec x and integration of cos x. I am keeping it up to you. Definitely watch these two proofs also, and please remember these four standard integrals. So add in your list of formulas. So integration of tan x is log of sec x, integration of cot x is log of sin x, integration of sec x is log of sec x plus tan x, or also it is in the form of tan log of tan of pi by 4 plus x by 2. Integration of cosec x is log of cosec x minus cot x, and it is in the form of tan also, it is a log of tan of x by 2. So these are the four standard integrals and these four corollaries that you have to remember from this today's session. On this positive note, I am ending this today's live session on indefinite integration, and I hope this will add your knowledge to this integration, which is a very important part of the calculus, and definitely it will help you in graduation also. So hope is beneficial for you. In I will cover problems on. Goodbye and take care of yourself and your family. Thank you very much for joining. Okay, Shruti says there is a one doubt to the Shruti. Are we asked to write a proof of the corollaries or just we have to use its formula? So see, if it is a theoretical examination, they might will ask you a corollary, proof of the corollary and a problem attached to it. But as far as objective examination is concerned, absolutely you can directly apply the answer. But in theoretical examination, definitely they will ask you a corollary and a question. If it is not, then please write down the standard structure of the corollary and directly you can mention your answer. So in theoretical examination, if it is a proof is asked along with one example, then please write down the entire proof that I discussed in today's session. But if it is a 2 marks question, then there is no need to write the entire proof. So just on the basis of observing the number of marks to this question, you can mention. But if they want the theoretical proof, they will mention in the examination. So don't worry about that. Shruti, I hope your doubt is clear. Okay, so you are always welcome. So here I am ending the session. Thank you, friends.